Every generation looked at technology with fear. The printing press, then the calculator. AI and robotics are the future of mankind. If AI was a clock, a 24-hour clock, we're only at 2 a.m. The decentralization of both the internet and the electrical grid will get things done faster. We're going to see the decentralization of electricity and gasification in the United States. But by the first quarter of 2026, you're going to have somebody that's about 1,000 times more energy dense than a GPU out on the marketplace.
Thank you for joining today. I'm Kinsey Grant Baker, and this is Energy Central's Power Perspectives. Just about every week on this show, we end up talking about data centers somehow, and no surprise there. These ginormous loads are truly redefining power needs across the industry. But today, we're going deeper than just we need more power delivered faster. We're getting into the nitty-gritty, the where, because where data centers are built has enormous implications for utilities across the board. And AI, it's increasingly impacting that where. So what does the future of compute look like, and where will it be? That's the question we are answering today with a fantastic guest. Pete Sacco is a data center builder, investor, and futurist who blends hard engineering with a spiritual, human-centered view of technology. In this episode, we'll explore how AI is reshaping where compute is built, what that means for utilities and communities, and why Pete thinks the next generation of data centers will be distributed, opportunistic, and energy savvy. Now, that's a tall order. I am ready to make it happen. Pete, how about you? How are you doing today?
Wow, that was awesome, Kinsey. From the preamble for this, I love it because you're exactly right. And so I'm fully prepared to talk about it. We live, the Chinese have a saying, may you live in interesting times. And while sometimes I feel like I've had enough interesting times, most of the times I embrace it.
I like that. Let's have an interesting conversation. We'll live in some interesting times together and have a wonderful, deep dive into all this, which I'm certain is very interesting for our audience. Now, before we get into it real quick, Pete, a quick note for our listeners out there. This episode is brought to you by Renew Developers. I will give you the full rundown on Renew in just a little bit, so stay tuned. Now, Pete, to kick us off, would you mind telling me briefly how you moved from studying quantum physics to becoming an electrical engineer and data center builder to launching Grey Wolf data centers? What's been the thread throughout that very interesting career trajectory?
It is. I'm a bit of a unicorn, even amongst my closest friends, right? You're not supposed to be 58 years old and being knee-deep in technology like I am. I attribute it to... Look, I'm lucky enough to do Family 2.0. So despite the mature appearance, I've got 7, 5, and 3-year-old girls, right? And so not my grandchildren, my children. I have a 37-year-old son too, and he's got 12, 9, and 2-year-old kids, right? So I'm that guy. But in order to build the world that they're going to live in, right, this AI-driven world, I have to, it's my obligation to have a sense of where we're going and what we're doing. So my background started in quantum. I became an engineer. I designed power supplies for the military during the first Gulf Wars. That led to the data center business. And the data center business, you might have heard AI is a thing. And so I got to be honest, when data centers were getting kind of boring, when the build out of the cloud happened, the guys who, like me, who understood the nuts and bolts of power and cooling were no longer in favor. But now all of a sudden, AI caught the data center industry napping, and I find myself playing with the cool kids again, because this time this one will be a paradigm shift for humankind. What I like to say is this: if AI was a clock, a 24-hour clock, we're only at 2 a.m. We're just getting started. If by noon, only halfway through the next 22 hours, by noon, we are not going to recognize the world.
Yeah, it's a really interesting way to kick off this conversation because I think it illustrates the stakes of all of this that we're talking about today, ensuring that we can get to 3 o'clock, 4 o'clock, 11 p.m., right? Ensuring that we can get there. We need the right infrastructure. We need the right planning and the right data centers and the right power for all of those data centers. So, Pete, I want to get a little more insight too here on what Grey Wolf specifically does. Can you tell me a little bit about the work that you do? Are there any patterns in data center design that have, stuck out to you in your career so far?
I think it's going to require a little bit of setup here. Let's talk about where the data center industries come from. right? So first we had a highly centralized mainframe computer, right? And that sat-centric, and that was hardware-centric. It was IBM-centric, right? That gave way to distributed processing. Let's call it the era of Microsoft, where the infrastructure, the compute infrastructure, was less important. It was all about software. And that software was being put everywhere on every type of device, a very distributed architecture. And that's given way to now what we have as the public cloud, right? And the public cloud, once again, is highly centralized. Granted, it's three players, Google, Microsoft, and AWS, but it's highly centralized, and their data centers are mostly in what I like to refer to as the American pro football cities of the world, right? And that's the cloud that we live with. And today, if you're an enterprise client, most enterprises went through something like this. I have my own data center. I don't want to be in the data center business. I'm going to go co-location. Co-location was born in the early 2000s, failed, then finally rebounded. And then cloud happened, and then I decided, nope, I'm a cloud company, and I started to move workloads out to the cloud, somebody else's cloud, the public cloud, and then I had to secure it down. But like my largest client, somebody like Pfizer, for instance, a global pharmaceutical manufacturer, realizes today that they have to have a hybrid environment. Some of my stuff is in the cloud. I'm cloud first, but not cloud all. Some of my collective intelligence sits in co-location data centers, not my facilities, somebody else's facility, but with my IT. And some of my stuff has to be at the edge. And the edge is an important picture because it's part of the hybrid data center, outcome. Let's evolve the data center picture now and talk about AI. Because when we're talking about AI, what we're talking about right now is the prevalence of building large language models. Large language models are basically really, really good pattern matching machines that are cued on the human language, and based on our words, it's memorized every word and calculates what's the instance that this word happens in the order and sequence that they happen. A giant pattern matching machine. Unfortunately, the data center industry was kind of caught napping, right? We weren't prepared for the GPU. The GPU uses an immense amount of power, right, in order to do what it does. I'm going to geek out a little bit for you, right? Why is a GPU even the thing? So it has to do with deterministic chipsets versus non-deterministic chipsets. A deterministic chipset is one that calculates and stores its value between 1 and 0. A CPU, a GPU, and an FPGA are all deterministic chipsets, and a CPU does serial processing really well, but parallel processing really badly. An FPGA does parallel processing like your brain works, parallel processing, but not linear processing. A GPU does a good blend of both of those, and it's become the darling of the AI industry and Wall Street at the same time because it can do deterministic processing with ones and zeros very, very fast, albeit at a huge amount of energy. Now, quantum is the future, and quantum is completely non-deterministic, meaning it can hold in its value any number between 0 and 1. And I'm not going to geek out as to why that's important, but if you can do that, you can start doing computations really, really, really fast. And so because of that capability, GPUs have become the darling, and we can do immense amount, but at a power premium. So when we started to deploy that, the deployment of them was no longer a 7 kilowatt rack, a 10 kilowatt rack, a 20 kilowatt rack. All of a sudden, it was a 50, an 80, 120. NVIDIA just last reported that their future thing is a 500 kilowatt rack. I mean, that was the size of data centers a few years ago. And so we've had to reinvent what the data center is in order to accommodate that. Now, so far, those large language models have been built, like I said, in the what I like to refer to as the American pro football cities, New York, Dallas, Chicago, Los Angeles. And then there's 3 major providers in there. And so that's where they're going. So to your audience, the electrical utility providers, what we've done in the world is we don't have a power production problem per se. What we really do have is a power storage and transmission problem because we're running out of power in very specific areas. Enter Virginia, right? Maybe the most populous data center state. And, they're hard pressed to be able to react to the massive amount of building because of the presence of the U.S. government and its centralization to the East Coast in order to be able to respond to that. And so I guess the answer is going to be that there's going to be a couple paradigm shifts. And the paradigm shifts are going to happen twofold. One, they're going to happen in the data center layer. It is Now, finally getting to what Gray Wolf Data Center does, it is my belief that once large language models continue to proliferate at massive scale, and I'm literally talking, these people are no longer talking tens of megawatts. They're not just talking hundreds of megawatts. They're now talking thousands of megawatts per deployment. That is the model. When we question the model, prompt as human beings, or inference, the inference is getting information from the model. It is my position that as we transition from a world of AI devices, one that it's not humans doing the prompting, but the devices themselves, enter the scary word, robots, because that's where we're going. When the robots are going to be inferencing, asking the model questions, that answer is going to have to happen near the edge. I believe the way that is going to happen is there's going to be a proliferation of data centers throughout the United States, not in the American pro football cities, not even in the college cities, the NCAA cities, which is really where the data center market is growing out right now. Like, in other words, all the data center operators, whether it's infrastructure as a service, software as a service, platform as a service, they're building out in what I call the Division I cities. Inferencing is going to have to happen at the high school football cities of the world, meaning everywhere. And I've got some distinct opinions about it. I think it's going to be an array of independently owned and operated data centers that share on a DAO, a distributed autonomous organization, very much like Bitcoin, right? Where they get rewarded for the amount of compute that they contribute to the DAO. But that's a completely different model than the highly centralized AWS stack, Google stack, Microsoft stack, right? I love when I talk to an enterprise client and they say, no, we're multi-cloud. What they mean by multi-cloud is I bought 3 companies, one that's on AWS, one that's on Google, one that's on Microsoft. But, you can't just take your AWS workload and shift it over to Google Cloud like that. You're really beholden to that environment. I believe, going back to my original story of highly centralized mainframe, decentralized software, highly centralized cloud, we're going to enter the domain of decentralized compute, grid computing, and that's going to happen at the inferencing level. And finally, to come full circle, that's what I want Gray Wolf Data Center to be. The proof of concept data center that I could build anywhere in any high school football city of the world for any AI optimized load, but especially inferencing that will be between 2 and 10 megawatts in size, that can do direct chip cooling, and that I do not even need to be tied to the electric utility. I could be tied to a natural gas utility and gasify parasitically on site in order to create the power that I need at the scale that I need, at the reliability that I need. And that's what Gray Wolf Data Center, I believe it will be the first of the DAO participants that will share the inferencing workload of the US.
I feel like, Pete, you should be a professor or something. Like, that was such a rich and context heavy answer. And I appreciate you giving some of the important background of where we started with all of this and where we're going. I think in the utility industry, we have a tendency to say, well, we could do the proliferation of air conditioning, which we could, but where are we headed next? So we don't get, again, to use the turn of phrase that I love that you had here, the data center industry caught napping, right? How can we avoid getting caught napping in the future? And this idea that there are simply going to be more data centers in these high school football kind of cities is really compelling, I think really interesting, and is a good chance here to get a little bit more perspective on the work that you're doing with Renew developers as well. Renew developers and Gray Wolf have a strategic partnership. You deliver data center environments engineered specifically for high performance computing and artificial intelligence infrastructure. So tell me a little bit more about what that service, what that offering looks like, and why you partnered with Renew developers to do this.
Yeah. And so to even back up a little bit, so I am the founder of PTS Data Center Solutions, which is a design build company that operates under Intuva, Future Proof Your Data Center. So it is the design builder of data centers for other people. My predominant customer is the US government, right? And then I do it for large commercial enterprise, people like Pfizer and a whole host of people there. And then some of the data center operators, people like CyrusOne is a big client, right? Then CyrusOne enter Gray Wolf Data Centers, because Gray Wolf Data Center is just another data center operator But in order to be a really good data center operator, you need to be a really good property and land developer, because you need to handle the acquisition of the site as well as you need to handle the permitting of the site. So my partner Renew and I, when we form Great Wolf Data Centers, we purchase land, then we take the land and we improve the land by putting a power pit permit on there, and then we either A, tie back to the electric utility, or B, we tie to a gas line, and then through many different ways, could be gas turbines or linear generators or solid state fuel cells, we gasify that and turn it into electricity parasitically, meaning only for the property by which we're operating, not selling it off to anybody else. We don't want to be a utility provider, right? And then so we build that power behind the meter, and then fill in the blank. It depends on how the data center operator wants to be. Either I'm selling them the land and I'm a power off taker, or I'm building the data center and operating the data center, or maybe I'm building the data center and deploying the IT load, and I'm OpExing them the whole environment. Gray Wolf Data Centers will do any one of those approaches. So it could be purpose-built to their specific load, because what we're seeing today is there's a couple different choices as to how you build an AI workload. And I think what's important to recognize for your audience, the electric utilities, is the advancements in the amount of chipsets that are about to be on the marketplace. It's not just going to be GPUs. It's not just going to be Google's TPUs, right, which are really exclusive to Google, right? But you're going to have AMD enter the game, because you're going to have people like Lemurian Labs that are going to make a full stack software that can compete against NVIDIA's GPUs with their software CUDA. But you're going to have somebody like Lemurian that will build a full stack software that I could put NVIDIA's GPUs, AMD's GPUs, anybody's GPUs in my data center, but then operate a singular stack of software, not their specific software. And then after that, you're going to see even newer chipsets. I'm an investor in a company called Extropic, EXTROPIC. And now I'm going to go back to why I told the story between deterministic chipsets and quantum, right? What if we could have a chipset that could calculate between 0 and 1 and hold in its bit of value between 0 and 1, but do it at room temperature and do it far more energy efficiently than a GPU? Would that be valuable? And the answer, it would really be valuable. And that's what Extropic is doing. And so Extropic is using the laws of thermodynamics to build their version of a TPU. And they are about to release, in partnership with their chip manufacturer, I'm not going to say who, because I'm not sure that they made it publicly announced, but by the first quarter of 2026, you're going to have somebody that's about 1,000 times more energy dense than a GPU out on the marketplace. And so that's going to change. So I know the next question that everybody asks me, well, Pete, if that's the case, and we can get 1,000 times the level of compute for the unit of power, wouldn't that mean that we're not going to burden the grid? And the answer is, we're human beings. Of course it's not going to work that way. What it means is we're going to use this new level of compute. We're going to build massive data centers with 1,000 times more compute, because you remember what I said about AI only being 2 hours into it? At 12 o'clock, we're going to need tens of thousands times more compute than we have right now if we are going to change humanity for the better. And because these are the types of changes that are going to happen. So the answer is, unfortunately for the utility industry, is the AI industry is extremely well heeled. They are not going to wait for the electric utilities to build. They are going to find a way to get the power any way they can, because they will not be denied. And that is the sad reality. That's why we're going to see the proliferation of electric. We're going to see the proliferation of natural gas. We're going to see the proliferation of hydrogen. We're going to see the proliferation of nuclear. We're going to see the proliferation of new battery technologies. AI is advancing material science and battery technology at a feverish clip so that we improve BESS and microgrids. We're going to see improvements in the way gasification happens at turbines and solar. Think about it right now, you know, solar only captures about 18% of the energy sun, so it's not viable. But if you go on the Mars rover, they capture 98% of the energy in the sun. It's really, really expensive solar panel, but we'll commercialize that quickly. So the answer is that energy is going to turn into decentralized approach. Then I'm going to opportunistically take the resources that are available to me at the property by which I acquired, and I'm going to combine those energy sources to meet the demands that I need for whatever the workload I needed.
That was incredible. Pete, I think you were right that you did answer the question that I was prepared to follow up with, but you also opened a Pandora's box of many, many more. So the first one that comes to mind for me with this idea that and I think this also kind of ties in this concept that we talk a lot on the show about the way that the technology industry operates and the way that the utility industry operates. Their incentive systems are really at odds with one another. So how does the utility that wants to be part of this, revolutionary future of data centers, that wants to get past 2 a.m. in the proliferation of AI, how does that future-oriented utility find a way to wedge itself into this future? What does that look like? What role could that be for that utility?
Here's the beauty. And I love to scare the pants off them with the previous statement that the AI industry is not going to wait for them, right? They're going to do it anyway. But the answer is they have nothing to worry about. Because as fast as they can build based on their own, look, they have a whole bureaucratic nightmare that they have to deal with in order to get the government to be able to do all of this, right? As fast as they can build, it will get consumed. They're just not going to wait only for that. They're going to, the AI industry is going to consume whatever is the available. Here's the advantage that the electric industry has. The electric industry is still the least expensive power typically available. It's just not currently massively available in all places and at the scale that it needs to be consumed at. I'm working with a client right now in the southwest of the United States that just told me that they want to build 27 gigawatts of power by 2030. Let that sink in. 27 gigawatts of new load. One person. This is just one person's roadmap. Well-heeled, all the money that they need to, supply chain stacked. There's nothing that's going to preclude them from being able to do this but for access to power. They would be financed and capable of doing that if there was 27 gigawatts of power in the world right now in the Southwest. They would buy it tomorrow and deploy it by the end of the year. That's just how fast the AI industry can move.
So I guess the question that I have directly related to that example too is, knowing how a supply and demand curve works, how can a utility as a business take advantage of something like that?
I don't know. That's a great answer. I wish I had that answer. The answer is, look, in 2003, it almost imploded the utility industry, right? Because they built to accommodate this new thing called IT. Right. So everybody came to them and said, look, I know I only need, 5 megawatts today. In fact, in that time, we weren't even talking 5 megawatts. We were talking hundreds of kilowatts. Right. We need hundreds of kilowatts, but I'm going to need 5 megawatts in the future. And then it never came. The industry imploded. Right. And the utility industry wound up getting egg on its face. Right. Because they overextended to do all these build outs, all of which has since been utilized. Right. But there was a big gap between that. Hey, I build it and they will come. And it took about a decade for them to come. Right now, we're asking them to do the same thing. The AI industry will bubble and explode. It's inevitable. I mean, look at our market right now. I don't want to wax philosophic about markets right now, but who couldn't say and point to the market right now and say it looks like a top? It's looked like a top for going on 20 years right now. The answer is it's at some point it's going to blow off. But that doesn't mean that's the end of the world. That means it's just the blow off for us to regroup, retool, redo this, build more efficiencies, and then it will explode into yet another exponential growth period. So the answer is, look, is the world expecting that the utilities are going to go out and build for this demand right now? We would love it if you did. We just don't see the I personally don't see the practicality in doing that. So I think we're going to see a distributed, opportunistic approach to power. All of the people that I'm talking to right now that are looking for thousands of megawatts in the gigawatts, these will be mini utility providers. We will build them just like electric utilities. Why do we think GE and Mitsubishi are tapped right now, the two largest manufacturers of gas turbines in the world? Because fill in the blank with every name that you know as an AI provider, they're buying it all because they're going to basically drop it on land and become small utilities for themselves. And we're just going to be awash with that, I think, forever for now. I don't think it'll ever go back that there'll be a sole centralized electric utility. We're going to decentralize. Look, I tell a story all the time about the effectiveness of decentralization as to why I think, look, if you ask me my massive transformative purpose is one is to live awakened. That's a whole different, that has to do with the book over my shoulder that I wrote called Living in Bliss, right? That we'll all become way better human beings in the future than we are right now. Let's put that one aside. Second one is to champion decentralization. When we began the program for SETI, the Search for Extraterrestrial Intelligence, bear with me, I know I'm way off the mark here, right? But when we had to do that, and we had to take radio telescope pictures of the sky, the night sky, to search for intelligence, we knew that the data center for doing it could only handle a certain amount of data. So what did they do? They decentralized it. And they said, hey, anybody with a radio telescope, this is the commonality. Let's all look up into the night sky and stitch our pictures together to search for this intelligence. Well, look, they never found it, not yet, but somewhere between 50 to 100 times the capacity was delivered because they decentrally solved the problem. Let that sink in. This is going to be the same answer for the internet. This is going to be the same answer for the electric utility. This is going to be the same answer for mankind. Decentralization is a better roadmap for the proliferation of any technology. We are going to see the decentralization of the internet and cloud. We are eventually going to see, and we are at the parallel, since the internet and cloud are delivered by power, we are going to see the decentralization of electricity and gas distribution in the and gasification into electricity in the United States.
So if all of this is the direction in which we're headed, if we are going to have more decentralized power systems with a lot of these mini utilities, as you called them, tell me a little bit more about what the mini utilities look like. You know, what's on site? What are you at Grey Wolf and at Renew? What are you seeing and predicting and expecting in terms of, you know, on-site generation, permitting, clean energy? Tell me a little bit more about what they look like.
Sure, absolutely. At the big scale, the big players are going to do exactly what the electric utility providers do. Right? It's going to be massive GE engines or gasification with gas turbines out there, and they're going to be the gas turbine facilities just like the utilities build, but they're just going to be for a single campus, right? And they will just use it for themselves. Permitting is going to be as problematic and as litigious and as everything as it is for everybody. The beauty one is the smaller scale. What I was talking about, the proliferation of the smaller data center. Because here's what it looks like there. Here's something that I'm going to be speaking at the Supercompute 2025 out in St. Louis. And there in my booth, I'm pitching there because there's lots of universities there, what I call the zero waste campus that I've been developing with Renew that we could use for data centers, or I could use for a university campus, or even hospitality if you're a hotel operator. All right, stay with me. Here's how I can actually produce power parasitically for, let's say, a university. Now, know that a university produces lots of garbage and they have lots of food, right? So they consume lots of food for students, right? We can take a technology of a newly patented version of pyrolysis. Pyrolysis is the act of taking any carbon-based refuse and applying heat, lots of heat, 2200 degrees, but without oxygen. So therefore, I'm not incinerating garbage, I'm melting it and creating syngas out of it. So I take waste to syngas. I now take that syngas, combine it with natural gas, put it into, at smaller scale, 2, 5, 10 megawatts, the size of a typical university campus. And then I take that syngas and I run it through maybe a gas turbine, maybe a solid oxide fuel cell from like Bloom Energy, maybe through a linear generator from Mainspring Energy. I'm going to gasify and turn that into electricity. That's not hugely efficient. So I'm going to take the waste heat off of that and I'm going to run that to, let's say, maybe a vertical farm. And I'm going to create food for the campus. And then I'm going to take the power and I'm going to power the campus. Maybe I take some of that waste heat and I run it through an absorption chiller and I actually create cooling for the campus data center. That the school is teaching sustainability and teaching this. So they're operating their entire sustainable zero waste campus, but in a new, completely different mode and completely detached from the electric utility if they choose, or tie it back to the electric utility, throw a microgrid controller in there, and now you only have to do portion of the load. And so there's just an example of what we're piecing together in the engineering world to be able to go to a university and say, look, you have more options. Look, they all tried it. They all put giant, those guys who could get the funding, they put in big fields for solar. But solar didn't have a lot of density. And then they tried combined heat and power, but that they realized was highly complex and difficult to maintain. And so it never really caught on. This is going to be far simpler. And so the answer is that they're going to opportunistically be able to build a very sustainable solution. And that's what we do that at Gray Wolf Data Centers for our own data centers. We'll do it for a campus. We'll do it for anybody who has that. In the hospitality world, one of the things we're doing is that same process of processing the garbage from the hotel chain and all of their stuff. But instead of taking the heat and running it into a vertical farm, how about we build a giant lagoon? Go into, like with Florida and Texas, and we're building lagoons that are heated using the waste heat off the gasification process and as part of the, part of the hospitality campus. And so this is just some of the applications that are being born right now that weren't even available to us just a few years ago, but why this idea of distributed energy production is going to change everything.
Yeah, it's really, really interesting. I appreciate the examples. It brings to mind a question for me specifically around, with these large industrial power users, what is the timeline like for getting to something like that? When we're talking about the difficulties and the intricacies of forecasting paired with the need to borrow from the tech community, move fast and, hopefully don't break anything, but move fast, right? What does the timeline look like? And how does, the work that you do with Gray Wolf and Renew, how does that potentially expedite that timeline for these large industrial users?
It's hard. It's not an easy answer. The answer is to build any of this is still the same answer that was last year and the year before. It's 12 to 18 months to do all of the things that you need to do to build. And that's a long time. And a lot of people are not. Just prior to you, I was on the phone with a potential client calling me. He's like, I need 40 kilowatts by the end of December. I'm like, okay, where would you like it? Oh, I need it to be in Dallas. No, not even Texas. He needed it in Dallas. I'm like, okay. Would you like the scale between 1 and 100 of your chance of finding that? It's -2, right? There's just not power to be able to do that, right? A 40 megawatt contiguous sitting waiting for you. It's just not available. And so there's a lot of learning that has to go on. And look, and in the funding world, to build any of these data centers, what does every financier want? Well, Peter, do you have a client right now that's giving you a commitment that says in 12 months of you building this, they'll commit to taking the load? That's the way it works right now. What's starting to happen is that the demand is so high of people who want it right now that the private equity industry, the financial people, are starting to say, look, if you've got a good idea and you're in a good area, we commit to the project. We're going to start financing these projects so that you can build even before you find a client. Because the answer is, once you have that availability of power and permits and a building, and hey, you can move in tomorrow, unfortunately, I can charge them 3 times the price because there's just not anybody available to be able to do that. So that's what's starting to shake out right now, is that the money is starting to flow to, hey, let's just opportunity, which, by the way, is also the beginning of the end. Because when you build it in anticipation of they will come, that's when the bubble eventually bursts. Because everybody starts to get on board, and then there's a glut of build, and there's not enough people to fill it. We've seen this model in the world, in the United States especially, over and over. Here's the good thing. we're only at the very beginning of this. So for the next few years, we're going to be able to build on spec and people will consume it because AI is still a new thing. Inferencing is not even yet fully realized. AI models are only megalithlically large being trained on public data. This is not even the Pfizer's of the world training on their own private data. And so we've got a long way to go. And by the way, that's just the large language models on human language. What about the large language models that have to be built on things like the human genome? The human genome is way larger parameter stack than the human language, than English. That's going to require a beyond GPU capability to build that large language model on the human genome. But play it all the way out, Kinsey. When we train a model on the human genome, we've solved every illness, disease, and longevity forever. So the stakes are really high. So when you hear that Google is spending fill in the blank, right? Right now the numbers begin with B. Soon they're going to start talking about numbers that begin with T, right? Trillions of dollars. It's because the evolution of humankind lays in the balance. Yuval Harari wrote a book, Homo Deus. Homo, man, Deus, God. Man is God. The book starts like this, and this is about as philosophical as I'm going to get on you. Man spent the last millennia trying not to die by disease, famine, and war. And as a result of AI, mankind will live as gods and live forever in the next millennia. And I fervently believe that with every fiber of my being. No technology has ever destroyed mankind before. This is not the technology that's going to do it either. If we treat it with wisdom rather than fear, it will push us to what we've always hoped for, a post-scarcity world. But getting there is going to be some of the most dystopic times in human history. Because in essence, right, AI is going to beget robots, and robots change the world.
But I think it's a good way to really, round out this conversation that, it's almost a little funny and interesting that we started with, where is compute going to exist? What does it mean for utilities? But it expands into a much larger and much more, impactful conversation than just where we're building data centers, because that informs so much about the future of the technology that we have access to, of the things that we are capable of doing, of the, the goals we're capable of setting and exceeding. I think it is all related, and it's, I think, an interesting element.
Absolutely. Here, I'll leave you with this. Think about this from the left. If you're still pondering, well, can AI really consume this much power? Let's take this. AI is required for robotics. There's 18 major robotic companies in the world. Right, the two biggest one in the United States being Figure AI, Brett Adcock's company, and Elon Musk's company. Right, let's imagine for a moment that I can tell you that right now the robot companies are gearing for this level of growth. Okay, first of all, a little preamble: 59% of worldwide GDP is as a result of human labor, people picking things up and putting things down. That's $42 trillion a year. There's 3.3 billion households in the world, roughly. And there's 400 million people at the end of 2026 that are going to require elder health care. And there are not enough nurses on the planet to do that. Enter robots. By the end of 2026, we as human species will realize about 1 million bipedal, automatic, autonomous robots that will do everything we can do, but better. By that number, we'll go from 1 million to 1 billion by 2030. And by 2035, that'll go from 1 billion to 10 billion robots on the planet, and that's more than people. And how do we power robots? Electrically. There is no end in sight to the amount of power that is going to be consumed at this point in the world. AI and robotics are the future of mankind. It's maybe why we're even in existence, to make them exist. And so, but again, that gets a little bit different story, but there's no end to this. We're just at the beginning of the hockey stick of exponentiality that we are about to experience as human beings.
All right. And I like being at that end of the hockey stick. It's a very interesting time to be alive. I'm sure everybody always says that throughout the, annals of history. Everybody has felt it's an exciting time to be alive, but it does feel exceedingly exciting right now.
Every generation looked at technology with fear, right? Think about it. The printing press. When Gutenberg invented the printing press, they were destroying them in the street because it was going to replace humanity. Then the calculator. Remember the days when they told you can't have a calculator in school, right? Now we carry a calculator that can order food and we can, tell us if we're emotionally available. So technology, we've constantly, it's been, every generation has been defined by the technology. This generation is being defined by AI, and this is revolutionary. I get this one's different, but I don't think it's going to destroy the world. It's going to be the greatest invention mankind ever wrought.
I'm going to quote you on that one, that it will not destroy the world. When I go to sleep at night and I get panicked about a robot taking my job.
There's enough negative people. I'm going to be our optimist.
I appreciate it, Pete. So we have come to the point in our conversation where we're going to transition into our lightning round. So if you don't mind, this is supposed to be rapid fire. Quick little answers. My first question for you here, and I feel like we've talked a lot about exciting stuff today, but I'm gonna press you one more time. What's the most exciting aspect of this moment in time at the intersection of data centers and energy? What do you feel most invigorated by?
Yeah, the decentralization of both the internet and the electrical grid. That will get things done faster because we'll be working on the problem from many, many different angles.
Many hands make light work. All right, next question for you. If you could leave utilities with one urgent takeaway about data center demand, what would it be?
Build as fast as you can because you'll be rewarded for it eventually. It might be the same as 2003 where, there was a period of retraction before the growth, but in the end, anything that you could possibly build will be consumed.
Final question for you here, Pete. Can you recommend a book for our audience of utility professionals? What's on your must-read list?
Okay, wow. So you mean other than the book over my shoulder that I wrote that is available? So, my book is Living in Bliss, Achieve a Balanced Existence of Body, Mind, and Spirit. It's a completely different cathartic tale of my last 30 years of my life where I stand at this juxtaposition. But, look, if you want to get a sense of the world from a positive standpoint or the book I just mentioned, Homo Deus from, Yuval Harari, I think is an excellent book talking about where this world goes with AI. There's so many people right now solving the problem. I guess the problem is we're being deluged with information faster than we can consume it. And so, yeah, that's a hard one to narrow it down to one.
Well, I would hate to have to narrow any of my book lists down to one either, so I'll let it slide. Pete, thank you so much for joining me today on Power Perspectives. I truly learned so much. My notebook is filled with little, chicken scratch ideas of things that I want to investigate further or read more about. So I really, really appreciate you walking me through all of this. I'm sure our listeners appreciate it as well. So thank you so much for spending some time with us today.
Kinsey, it's been a real honor. Thank you. And I thank you for allowing my verbosity because, look, there's no way to separate all of these topics. They're all coming together at this time and point in history. And that's a great thing. We need to keep our eye on the ball, that it's a good thing, not a bad thing. So thank you for the opportunity to be heard.
Of course. Thank you again. And thank you, as always, to our listeners. And I want to give a shout out to our partners at Renew Developers for making this episode happen. Here's a bit more about them. Renew Developers is a sustainable real estate development firm offering speed to market power solutions and energy as a service. They serve data centers and large industrial power users by developing modern projects with on-site power generation. Renew Developers' unique approach shaves years off the timeline to move into your data center. They have a pipeline of land with energy generation permits in place that can feed your state-of-the-art data center expansion needs. You can get in touch with them at renewdevelopers.com if you need land with power now. And we'll toss that email in the show notes too, so be sure to check those out. Thank you, as always, for listening to this episode of Power Perspectives. Take care, and I will see you next week.